When do you go material specific when you're looking at end mills? What are the criteria? What even makes sense? Do you just automatically go to material specific, or do you start with general purpose and then go there when it's needed? Well, the answer is going to be it depends. Like much I find in advising and manufacturing, it really does depend. If you ever work with anyone and they say, hey, this is the only way, run fast, run far. Let's say you're right there, either you're tooling up for the first time on the job or you're looking at it as it comes back across your table. What kind of things do you need to weigh? Well, one, it's going to depend on the material. There are quite a few materials that machine well enough with your general purpose tools. There are some materials you absolutely can't do whatsoever without the right tools. And then there's other materials where it's just kind of nice to have the material specific. It could reduce post-processing or other things. Let's jump over to the Harvey site and have a look at some of their material specifics and talk a little bit more about that. Are you ready? On the Harvey site, right away, you see the material specific end mills right here. Under hole making, we'd have to click through, and then it's actually in the drilling section itself. And then you'll start to see some for the aluminum alloys, the composites, which if you're doing composites and you have not tried these brad point drills, try one now, 100%. If you don't want to struggle with delamination, snapping drills, excessive wear, switch to these drills. Let's say you're tooling up for a job and you want to check out the material specific end mills. Let's go over some of what's there. Now, depending on how hard your material is really going to depend. Can you actually tackle it with a general purpose tool, or should you go material specific? Anywhere up to that 40, 42 hardness Rockwell, you're going to be okay with general tools. You're going to see a little bit of a performance increase when you go material specific, but unless you have the volume or the amount of machine time necessary to justify it, you can get away with just your general purpose like a TICN or TLN coating or whatever. But on the hard side, you would want to be looking at your high temp alloys and specialty tools, because on the hard side, once you start getting over that 40 Rockwell mark, you're going to have a hard time and a bad time using general purpose tools, and your cost for tooling is going to go through the roof because your consumption rate is just going to be so much higher. Aluminums, well, as long as you don't have aluminum in your coating, you'll do okay. A TICN in cast aluminum or in wrought aluminum, not a big deal. The specialty tools are definitely going to take you to that next level. You know, you're going to see upwards of a 60% spindle time reduction to process that job. It's definitely worth it if you have the volume. However, if you're in a jobbing shop and you're only doing a handful of pieces, not a big deal. If you're in a jobbing shop that does a lot of aluminum, you would still want to be looking at these material specific end mills. And then if you do an obscene amount of aluminum or need a lot of high surface finish, you'd want to be looking at the diamond tooling. They're more expensive. The value balances out in the long term if you have specific sizes you go to all the time. Your costs for the job will actually go down, even though you're going to be spending more per tool. Now, I already mentioned the brad point drills. Composites are another time. The way that they have these compound cutters, they really do support you to avoid delamination and a lot of secondary post-processing and scrap by using the proper cutters to at least get the finish on there. It's no fun for anyone, and it adds a lot of labor when you've got to deburr these parts by hand in the end. Plastics, if you've got a nice sharp carbide that's uncoated, you can do a lot of the roughing and not really see any detriments. However, for your finishing, if you're doing a large amount of the different plastics or even some softer and harder durometers in rubber, then the plastic specific tools will help improve your material removal rates, reduce your spindle time, and avoid all that fraying on the edges. It's always a question of how much. So really quick recap. One, it depends what material you're cutting. A lot of the standard job shop materials, you can get by with general tooling. An all-purpose TICN coated tool will do you okay. You'll get about 60, 70% maybe efficiency. Again, it's going to depend on that material. If you're working in the extremely hard materials, you're throwing on some Nitronic 50, or depending on the grade of titanium that you're running, or Inconel 718, anything like that, you're going to want to go material specific off the hop. Do you absolutely have to? No. But you better be prepared to sink 3 days worth of labor into it instead of a few hours, right? It's all about that balancing game. Type of material, quantity, frequency, and well, always checking out those numbers. So having someone in your network that you can trust to look and help you break down those costs is always a benefit. Until next time, keep your spindles turning and earning.